the next part of this lesson has to do with the distributive law. And the distributive law is something that you used before. Now, what I'm going to do is I'm going to take two of the same question, and notice I don't have any variables here, and I purposely didn't do that so that we could actually look at it doing this question in two different ways. Now, the first way I'm going to do by following order of operations. Order of operations is going to make me do the what's in the brackets first. So I have 3 plus 5, which is 8. And so I have 2 times 8, which is 16. So there's nothing difficult about that, or there better not be. Now, when I'm talking about the distributive law, this is what it means. Right now it says 2 times everything that's in the brackets, and that's what this one said too. But in this case, I actually calculated the bracket first. This time with the distributive law, I'm literally going to distribute that 2 times into each term inside the bracket. Now when I do that, so what I'm doing is I'm literally going to times that 3 and plus, because there's plus sign, 2 times the 5. And when we do that, we end up with 2 times 3, 6, and 2 times 5 is 10. Add those together, I get 16. And notice that both answers are identical. Okay, so this is called the distributive law, this part right here. Now you're saying, why on earth would you do that? Because look how many extra lines there are, Mrs. Brodigan. And you're right, there are lots of lines here compared to this one. And normally, if I just had numbers, constant numbers, I wouldn't do it using the distributive law. I'd be using it by following order of operations. The problem happens is what's going to be in these brackets now might not always be constants. They might be variables. And that way I can't follow order of operations the same way that we do when we know what the actual number is. All right, so let's actually look at some questions with variables. Okay, so maybe I will put the screen back up, bring it down, and we'll look at the first one. So again, this time it says 2 times everything in the bracket. So I literally am going to go 2 times x. Okay, so that's 2x. 2 times a positive 3, which is a positive 6. And that question is done. Okay, notice it doesn't say x equals something. Also notice directly below the other line, I put an equal sign. So let's do the next one. Negative 4 times a 3x. So I'm going to put the negative 4 times the 3, so that's negative 12, and I have an x. Then it's going to be negative 4 times a negative 5. Negative 4 times negative 5 is a positive 20. Okay, the negative 12x and the 20 are not like terms, so we are finished. So moving on to the next question. Okay, this time I have a 2x being multiplied by everything in the bracket. So I'm going to take that 2x. It's going to be multiplied by 3x. Well, I know 2 times 3 is 6, but what about an x times an x? Well, an x times an x is based on exponent laws. Both of them are to the power of 1, so I have an x to the power of 1 times an x to the power of 1. Bases are the same. What do I do to the exponents? I add them. So really, x times x is really x squared. And now what I'm going to do is I'm going to go 2x times a negative 5. Now again, the 2 times the negative 5 is a negative 10. I have no problems about that. But what about the x? The 5 doesn't have an x with it. Well, it kind of does. It's actually like an x to the 0, right, which would be 1. So it does have it, but when we look at it, when we multiply it, so x to the power of 1 times x to the 0, add the exponents, it would just be x to the 1. So what happens here is if I am multiplying x's together, it increases the exponent value. If one of them does not have that variable, you're almost like just tagging that on to the actual coefficients that you've multiplied together. So let's do another example. Now, the next one looks a little bit harder. Now, it's not that it's harder, it's just that there are more terms in it. Okay, so this time I have a negative 3x squared being multiplied in. Okay, the coefficient in front of the x to the fifth is 1. So I have negative 3 times 1, which would be a negative 3. I have an x squared times an x to the fifth. Both bases are the same, so I add those exponents. So 2 plus 5 is 7. I then have negative 3x squared times a negative 2x. Negative 3 times a negative 2 is a positive 6. X squared times an x, which would be to the power of 1, which would be an x cubed. And then the last terms, I would have a negative 3 times a positive 7, which would be a negative 21. And it would be x squared because the 7 does not have an x variable. Right? Lots of practice with this, people, because what's going to happen is when we do solve for x, when we're actually solving things, uh, you have to have those skills down pat. Okay, so all we're doing now is simplifying. None of these terms are like. They all have the variable x, however, they're all raised to a different power.